Starting with our mission statement, we provide complete sensor solutions and services for our hygienic process engineers in dairy, food, and pharmaceutical markets. We not only manufacture sensors, but we provide complete solutions. We share our expertise with you and your end users to make sure we can solve their problems more efficiently, both in process and application. And pressure sensors are definitely part of it. So on today's agenda, we'll be covering a little bit about the recent product launches in pressure series, the L3, the accurate and temperature stable sensor that we launched in the beginning of 2017. We'll talk a little bit about the D3 that was launched earlier this year. We'll be talking about the new order code, which is shorter and simpler for MPF, and we will be discontinuing the TFP series sensors, and we'll cover the alternate products for those and how we are going to do the crossovers. Starting with L3, I would like to focus today on understanding the accuracy spec, which is 0.1% of the calibrated range versus some percentage of URL or complete sensor range in a traditional or some of our competitor sensors. We'll take an example of a traditional sensor that has an accuracy of 0.1% of the URL or the sensor range, and compare it against the L3, which has a spec of 0.1% of the URV or the calibrated range. The plot here will help us understand that difference a little bit clearer. Let's say we have a 500 PSI sensor for both the traditional and the L3. And if you look at that red circled region there, the sensors are at 1-to-1 turn down, so they are being used for its full scale. In that scenario, because both sensors have 0.1% of the URL and the URV, and it's being used for full range, the performance is going to be similar, so 0.5 PSI, and you won't see much difference there. However, as soon as you go to the red circle region here where the sensor has been turned down to 100 PSI, on a traditional sensor, the error remains the same, that higher value of 0.5 PSI, and that's because it's based on the full range, not the turn down range. Whereas in L3, we have optimized the performance for such turn down situations, and we can still achieve that 0.1% accuracy for that turn down value of 100 PSI. So in case of traditional sensor, your error will be about 0.5 PSI, whereas in L3, your error will come down to 0.1 PSI, and that's an improvement of 5 times better in case of L3. If you go further, if you turn down the sensor further and turn it down to 50 PSI, on a traditional sensor, the error remains at 0.5 PSI, and that turns out to be 1% of 50 PSI, which is a huge number. Whereas in L3, because it's higher than 5-to-1 turn down, the error is 0.15%, and in terms of PSI value, it's 0.08 PSI, which is a big improvement, again, when comparing against 0.5 PSI. So your L3 gives you more than 6 times better performance compared to the traditional sensor. So what these plots definitely make it clear is that when you have your accuracy spec mentioned with the complete sensor range, the URL, or against the calibrated range, the URV, it makes a big difference, and that difference could mean a big deal for for the customer in their applications and their measurements. So I would like you to understand the calibrated range aspect of L3's accuracy and how that could make a huge difference at customers' applications. Next, on the L3, I would like to focus on the temperature performance. It's best-in-class temperature performance across the wide band of 0F to 230F. Again, we'll take help of the plots to hit this message home. Here on the left-hand side, we have a typical sensor which has a 0.2% of accuracy at room temperature and 0.2% per 10F as its temperature performance. And on the right-hand side, we have L3, which has 0.1% of the accuracy at the room temperature and 0.016% per 10F of the calibrated range for other temperatures. And the small gray region there, 0.15%, is for the turn down. And you can see on the right-hand plot the small gray bar on top of the blue region, and that depicts the effect of the turn down. So in general, when you look at these plots, you can see that conical shape. As soon as your process temperature moves away from your room temperature, that error band keeps increasing. On a typical sensor, you can see as the temperature goes above 190 or so, your error could be as high as 2.5% or more. Whereas in L3, we have optimized the temperature performance and compensation technology, and even at 230F, the error band is still limited to less than 0.4%. So in a plant where the process could be of different type and your process temperature could change depending on what recipe you are running and what process you are running, this could make a huge impact. And that's where the L3 will add a value, because no matter what temperature the product is running at, your L3 will give you the repeatable and accurate and stable reading. Apart from that, one of the things that we sometimes keep getting questions on is the CIP and SIP spec of the L3. Want to re-emphasize that L3 is good for CIP and SIP temperatures for up to 266 F and for about 1 hour. So on general temperatures, CIP, SIP temperatures up to that, L3 should work perfectly fine. The other feature of the L3 is the switch output. It's normally open switch output, digital output, and it can be linked to the alarms, so the pressure set points, or it could also be linked with transmitter errors. So if your sensor is not functional or some other errors happen, you can use the switch output to indicate that. And apart from that, the other aspects of good things of the L3 is its simple user interface and the plain English menu structure that helps in easy reconfiguration if you need to change the pressure range or some other settings, pressure units or others. It's very easy to do, and it makes it much easier to commission or do some maintenance work. Heart and display has been included as a standard, and obviously it's a modular design, so it makes it very easier for field repairable and reconfiguration. So a direct mount unit could be made remote mount or vice versa. And also that modular design would mean you do not need to stock as many spare parts, and it helps customers lower the total cost for the sensor. Building onto the same platform of L3, we recently, in the beginning of the year, launched D3, which is differential pressure transmitter. Basically, for any closed pressurized vessels or anytime you need to measure a differential pressure across the filter or some kind of membrane, you can use D3. It has the same accuracy and temperature specs that we talked about earlier, and all those simple interface and modularity designs. One distinct thing about differential pressure that stands out when you compare with our competitors is the dual milliamp output. With the help of dual milliamp output, you can monitor your head pressure separately, or your total system pressure, the total pressure of the product in a system, plus the head pressure. Going to the D3 benefits, again, we talked about the best-in-class temperature performance, and that means your accurate and stable level measurement. Dual milliamp output, when you might want to monitor your head pressure, especially for your operator safety concern as well. You don't want your operators to be opening up the manhole or any other valves or other things when there's pressure in the system. So being able to monitor that head pressure separately using your milliamp output that can be connected to your analog input card in PLC could help or could make that process very easy. In our competitors, you can access those information only through HART, or you would need to buy a second transmitter to get that head pressure milliamp output, which is an additional cost. So in D3, you can get that information both through HART and through the local milliamp output. So that simplifies the process very much. D3 also has the simple interface, so again, making it very easy to change some parameters on the fly in the field. And because of its simple menu structure, local operators and engineers can do it very easily. And that means your plant can keep running. You don't have unplanned downtime too much. The modular design of D3, like L3, also makes it easy to change the configuration in the field. The heads are universal, so swapping them would be very easy. It's independent of the sensors, and because of its modular design, if you have a damaged diaphragm or something, you can change only one sensor at a time. This lowers your total cost of the ownership for your customers, and could be a huge advantage. So we covered the L3 and D3, the recent innovative products that we launched, and now I would like to focus on the MPF, the change in the order code for the MPF. The previous code was 30 characters long and had some non-value add codes in there. So on the new matrix or new order code, we are going to replace some of those fixed codes, and we are also using only one character to represent the URL instead of 4 characters that we used to use before. So the crossed out fields will be removed, and then the red box region where you see one character, on the old code, order code, you would see something like 966C or 971A or 984G. All those things would be converted into one character based on the table that's shown there, and the final matrix is going to be 22 characters long. So we have basically removed 8 characters, and it's much shorter. It's still similar, so that there's not much confusion on how the unit needs to be spec'd out, but it's much shorter and simpler compared to before. This is a screenshot of the new matrix code, and the green region shows the new order code for the URL, and the red region shows how it used to be before. And I have some examples that I'm going to go over, but I'll just keep it here for a couple of seconds just to observe the difference here. And this new matrix for the MPF, the order code, will be put in the distributor portal, and you will be able to access this beginning Monday. So any new orders coming in beginning Monday will be converted to the new matrix code, and we will be talking about the PER later on. That's associated with if you were to provide the new matrix code from the beginning instead of customer service here converting it to the new code. Here's some examples. It shows the red crossed out characters are the ones that we removed, and the blue characters there shows you what gets converted from what to what. So on the first one, the 966C is getting converted to 6, which is based off of the table that we showed you earlier. So on this 966C basically means 30 psi compound sensor, and the new code for it would be 6. On the second example, you have 981Z, which is a 500 psi gauge sensor, and the new code for that would be 8. Similarly, there's a new matrix code for the sensor or the stem only order. So again, it follows the same path, and some of the fixed characters are removed, and 971C, which is a 100 psi compound unit, is going to be represented by 7, and 966A on the next example is going to be replaced by A, which is for the 30 psi absolute sensor. And the last two examples here are for the enclosure only orders. That's for the transmitter head only orders. And from before to after, we are just removing the last 3 characters at the end, which we're not adding much more information in terms of how the sensor was being built up. So like I said, this new order code will be in the distributor website portal, and the customer service will be equipped to transfer the old matrix code to the new one if you have any questions on those. And last but probably the most important aspect of on this webinar is the discontinuation of the TFP beginning September 15th. So that's about 3 months from now. This slide here shows you the quick guide for a selection of the alternate product series. TFP is one of the main feature of the TFP that's not present in the other product series. Is its remote mount, which goes up to 400 F process temperature, and it's used especially in the UHT applications. We will have a new alternate for that one, which will be the remote version of the SR, and we'll be updating our SR order code for that one. But apart from that, all the features of TFP, the hard, different fitting options, relative and absolute ranges, and other temperature aspects that are all covered by L3, MPF, or the SR. And as a general guidance, when you are selecting these alternatives, the first thing we recommend you is to go towards L3, because like TFP, L3 has hard included as a standard, and for most applications with process temperature below 230 F, L3 will be good. The only reason you would want to go to MPF would be if you need a higher temperature, like 350, up to 350 degrees F. And if you need different feeding options, MPF has much more options in terms of feedings. Also, if you need absolute sensor ranges, currently L3 doesn't have it, so MPF would be your option for that. And the only reason you would go from MPF to SR would really be for that high temperature applications where you need the sensor to be mounted remotely and you have the requirement of 400 degrees F. And for that, like I said, we will be introducing the remote version of SR and will be added as an option in the SR order code. That's basically all I have. Thank you for attending this webinar. And with that, I would like to open the floor for any questions that you have. You can type your questions in either the chat section or the question and answer section. Okay, one of the quick question was, is there a tool or is there a way to cross over the TFP part number to other part numbers? There will be a tool. We are currently working on that, and it's very close to getting done. And customer service will definitely be using that tool to cross over the parts. And we are actually looking into if we can make that public and put it in our website, or at the least maybe share it with their inside sales team so that they could use that tool and cross over the part numbers before even placing a request for the order. The other question was, can we still place the MPF order with the old code? You will be able to order those, but customer service will probably be contacting you back with the new order code and confirming it. Everything that goes into the in our system going forward will be with the new matrix code for the MPF. The other question was, will TFP be removed from the JD? Yes, it will be removed, and that will be done as soon as we have the SR order code made ready. When SR has the remote version, the JD brochure will not have TFP in it. Some questions on the lead time. The lead time for the alternate products would be similar. Currently, L3 has the 10 days lead time, and we are working on, we have invested our resources on improving the lead time for L3. So it should be getting down to 6 days in very near future, in a month or so. For other products, for the MPFs and SRs, the lead time should be the regular lead time equivalent to TFP, less than 5 days. Okay, I'm not getting any other questions, but if you have any questions on the MPF new order code and the TFP obsolescence, please feel free to contact the customer service or myself. We have actually just uploaded the new matrix code, new order code into the distributor portal, so you can go ahead and access it and look at it. And if you have any questions, just feel free to contact customer service, and they should be able to help you with that. For the TFP, any product that goes out of the building will now, going forward, will have a letter to make sure the end users are aware of discontinuation of TFP, and we'll give 3 months buffer from now onwards before we completely stop taking orders for the TFP. Again, thank you all for attending, and please join us on our next webinar 2 weeks from now. Thank you.